Hi, everyone. I'm Bo, co-founder and CTO of Blink AI Technologies, and I'm here to talk about using machine learning for perception more upstream to what we've just been hearing about. How can we allow machines and robots and cars to be able to see at all in challenging visual conditions? So I don't need to tell this audience that the world is increasingly relying on visual information. Cameras are being embedded everywhere, all sorts of devices, vehicles, robots, IoT. But one of the critical performance issues that almost all these cameras are going to have is how they perform in low light conditions. And one of the reasons why is because these sensors are getting smaller and smaller on average to reduce cost, and they have to be smaller sometimes to fit onto often mobile, small physical packages. That means that you have less light intake coming into your sensor, which is the source of your information. Furthermore, as we're going into higher and higher resolution applications, now you're subdividing your pixel into your sensor into even smaller subdivided pixels. That means we have ultimately poor quality images, and it's not just sort of from a human perspective aesthetically bad looking. As we all know, reliable imaging is important to computer vision, especially in low light conditions where they really need to be robust for safety critical applications. So here's a frame from the onboard video of the now famous Uber self-driving car crash that happened last year. 1 second before the crash, the pedestrian was completely shrouded in darkness and unseen beyond the headlights. This caused misclassification by the system and resulting in a fatality, unfortunately. So when we think about how we can allow cameras to see better in the dark, the typical approach is to think about just capturing more light, capturing more information. That certainly can work, but it's a expensive hardware solution. And is there a complementary computational approach that we can be inspired by? And so we've been inspired by actually how the human brain learns to see through this amazing process called perceptual learning. Your brain actually trains itself how to see and how to interpret the raw neural signals that are coming through retina, which are actually incredibly noisy. And that's what gives us as humans such great, efficient biological vision, especially in the dark. So our technology is to recapitulate this process with artificial neural networks, putting a digital brain behind the sensor, fine-tuned to each particular camera model so that we can dramatically improve the performance of how these things work. We actually published the fundamental aspects of this in Nature last year, and since then it's received significant attention in the scientific community as well as in the media. And so as a quick example of this here, we see with the same exact information, the default JPEG, the default sort of video on the left, you can't see anything, but on the right, with the same data, same camera, we're able to achieve far better performance. And this is different from your typical, sort of Google and Apple low light, sort of applications that are using multi-frame averaging approaches. We can actually do this in real time on low power inference. And because we can do this enhancement, now it enables your downstream perception AI to perform much better because you can actually see what you're trying to detect, right? And we also have approaches to be able to do this in HDR conditions, single frame, single exposure HDR, where we can tackle both high illumination and low illumination at the same time. So in summary, we've developed this proprietary machine learning platform to maximally extract imaging data in low signal environments. It's a computational approach that is compatible with upstream existing imaging hardware. You don't have to change your sensors, as well as downstream perception AI and computer vision algorithms. At the end of the day, we're talking about low-cost computation instead of high-cost sensors and lenses. And we're already collaborating with tier 1s and OEMs in the automotive and smartphone markets, but we're certainly seeking all sorts of interesting applications and pilots and co-development opportunities with industries that this makes sense to partner with. So smartphone, automotive, as I said, but also security, IoT, and robotics. So if any of this sounds interesting to you, please feel free to email me, see me here, I'll be here all day, or visit our website. So thank you very much, and looking forward to connecting with you.
Hi everyone, I'm Bastian from Rosero, a San Francisco-based startup building machine learning software for robotic vision and control. Our company was founded back in 2015, and since then we've been working with over half of the top 20 material handling equipment companies and all of the major robotics companies. Together, we automate piece picking, kitting, orientation, and assembly processes in warehouses and factories. So you can see some of our partners and customers here. So what problem are we solving? Essentially, as previous speaker Vincent already mentioned, we apply machine learning to allow robots to adapt to changes in the environment and enter new industries. So traditionally, robots are programmed to perform the same task over and over again, but they can't really adapt to changes in the environment. But now, with deep reinforcement learning, we're able to teach a robot to learn a wide range of different items, to learn to handle a wide range of different items or tasks, and that is the problem we are addressing with our technology. Vision and control software can allow this robot arm to recognize different items in this jumbo bin and then place them into another bin. Either you want to align the axis to either axis of the bin, or you want to place it gently, drop it quickly, and we are able to recognize objects that traditional 3D structuralized sensor cannot recognize, like this transparent packages. It's integrated with ASRS automatic storage and retrieval system, as well as warehouse management software, WMS. And the product onboarding process is fully automated and self-supervised. You don't have to pre-register the item. The solution is robust changes in the environment, including the lighting condition, and it's entirely hardware agnostic, so our software can work with all kinds of different robot arms and edit vectors. So, as you've already seen, we have two main products. One is called OseraPick as a piece-picking software for distribution center, and our second product, OseraVision, is a machine learning vision API for factory automation. There are three things that actually differentiate our technology. First, as you've already seen from video, our machine learning-enabled vision system can recognize objects traditional 3D structuralized sensor cannot recognize, like transparent packages, reflective surfaces, or deformable items like clothes. And our machine learning model can generalize across a wide range of different items, and no pre-registration is required. It's self-supervised, so it's fully automated. We can also do imitation learning or fusion learning to accelerate the learning process. So how do we do that? Here you can see a picture on the right-hand side. Essentially, we take images of the item, then our machine learning model will automatically predict the optimal grasp pose and grasp point, as well as orientation of the object. That is how we can actually pick clear bottles from a jumbo bin and then place them with the desired orientation on customer one. We also do semantic segmentation. On the left-hand side, you can see masks, bounding boxes for each of the item. And the blue areas on the hairbrush, that means pickable area. That means the machine learns to pick this hairbrush from the handle, not from the head. So customer can also specify where they want or don't want the machine to pick. In the middle, you can see we do post-estimation and object modeling. So we can choose the optimal place to place the item in the bin, so it will be more space efficient. We can choose to drop it quickly or place it gently depending on requirements. So two more examples of our system in use. We work with Denso and DensoWave, one of the biggest Japanese robotics company on this bento box assembly project. The challenging part is that each chicken nugget has different weight and shape, so you really cannot hot program it. And we work with the second biggest material handling equipment companies in the world, Dematic, for this warehouse automation project. We integrate our system with their ASRS system. So, if your company has any large-scale piece picking, packaging, assembly, or kitting tasks you would like to automate, come talk to us. Here's my email and website. Happy to answer any question afterwards. Thank you.
Hey everyone, I'm just going to start. My name is Karan Kashyap. I'm a co-founder and CEO of a company called Posh Technologies. We're a Boston-based conversational AI company. We came out of MIT NLP and Speech Lab last June. We're currently about a dozen people in the Boston area and growing pretty quickly. Personally, I did my undergrad at MIT as well as my master's in natural language and speech. And right now we're really focusing on the financial services market, predominantly mid-market financial institutions. Credit unions and banks are our beachhead market. So what we're really focusing on as a mission statement is basically enabling businesses to better connect with people through conversation. And that's a pretty big umbrella term there. We can focus on things like customer service, lead generation, help desk services, and so forth. But we're really starting with customer service as a pretty big pain point among financial institutions today. And the goal there is really kind of two-pronged. So as people become more comfortable talking to bots and people become more comfortable interacting with bots across modalities, including messaging and voice, we want to bring the ability for mid-market financial institutions to basically build their own versions of Erica or Capital One's bots, but without the price points. And the value there is pretty obvious. From a cost-saving perspective, the ability to automate routine conversations, and from a member engagement standpoint, to be able to personalize service and answer more questions quickly is a pretty great goal. In practice, we see the opportunity for conversational AI, but in industry, it's kind of been lagging. And part of the company formation is really around some IP that we developed at MIT that we were able to really make the core of our platform, and I can get more into that in a second. So, what we're focusing on in a broad sense, the thing that we have that's sort of differentiated and patent pending right now, is this term called context understanding. So basically, the ability for conversational AI to more seamlessly understand the link between what was said in the past and what was said now in the conversation. So, here's an example of a typical, banking transfer flow that we might encounter in practice. The member wants to transfer money to checking. The bot says from where. But instead of specifying an account, you actually change topics and say, I want to transfer. I want to know how much money I have in savings first. So, most bots are pretty okay about handling topic switching. So you might say, okay, I'm going to answer how much money you have in your savings account. But then you might come back to the first thread of the conversation. So this is a multi-threaded use case where you start with thread A, switch to thread B, and then kind of seamlessly come back to thread A. What we see in practice is that the platforms in the market, at least the ones we're really focusing on as competitors, can't handle what we call basic simple kind of thread switching or multi-threading. And this is a very common use case we see not only in financial services, but you can imagine if someone's trying to return a package to Amazon, or you have to ask them for their voucher number or return number. You might say, okay, what's your return number? And the question then becomes, where do I find it? Or you can find it over here. Here's my return number. So this idea of multi-threading is a big aspect of context understanding that we see is really lacking in platforms in the market. So that's a big part of what we focus on, not only contextual follow-ups based on single kind of contextual follow-ups, but also multi-threaded contextual follow-ups to essentially make conversational AI more human-like and more robust to ways that people will ask clarification questions and so forth. So we had that IP that we developed, and we really built a platform around this idea of context understanding. So it's a cloud-based platform, really focused on a developer experience. So we're providing basically the building blocks for building conversational AI solutions. Right now, really focused on sort of the financial industry, and then slowly expanding out from there. Context understanding is the core of what we're doing, but we're also focusing on connecting with legacy systems and other third-party systems to actually enable automation, not just answer questions. And then here's an example of some of the companies we're working with. So DCU is a $9 billion credit union in assets. They're one of our longest customers so far. We're kind of taking a multi-pronged approach with DCU. Combination of voice-based bots as well as messaging-based bots to really deflect not only the lower-hanging fruits in conversations, but also the mid-level conversations. Just saving time from authentication and saving time for routine question answering for their 300 plus reps in their contact center saves about 2,500 human hours. So thank you guys so much for your time. Really focusing on financial services, but we're also looking at opportunities in other verticals as well with our platform technology. Thank you.
So Subabuchi Batla, I'm with Zappix, founded by MIT alum who finished his MSc there. Essentially, we are what the Google person referred to as data first. So we are into the data orchestration more than the integration as APIs and everything else that people talk about in terms of how you enable the smart ecosystems of the future. So problem is everybody wants to shift to mobility as a service, especially we are focused on the connected vehicle space or automotive, including all the other industries. And what does not exist is any kind of data standard, any secure performance driven orchestrations for all the use cases, AI, ML, and even new services that people want to introduce. And the ecosystem players are not software companies at the core. It's generally insurance companies, fuel, charging, parking, connected back to the OEM and automotive telematics that come from the car, as well as dongles and all the other kind of data. And all of them are trying to say, okay, I've got APIs for something, but how do you orchestrate it for the use cases you're trying to develop is what we are solving for, which is what we call the last mile. We are kind of like the data plumbers, but the data scientists who don't want to spend 85% of their time plumbing for the data that moves their use case. If you look at where we operate, like I said, we focused on the connected vehicles segment. There's a spider web of companies we can address in terms of dealers to back to the OEM interaction, or even insurance offering, which is the most mature use case, the usage-based insurance use case, finance offerings. You can talk driver safety and loyalty programs that a lot of people are trying to drive towards. Also fleet services and how do you optimize that, whether it's the fleets of the future or even autonomous driving. And then how do you do, when cars finally become autonomous or vehicles become autonomous, how do you do automated services and all by telling the car what to do versus now a driver is punching an infotainment system and figuring out what to do. In terms of production use cases, this is our very first customer, they were trying to do an analytics dashboard that helped with fleet optimization for their fleet operators globally. It's 250,000 vehicles producing data, integrating with their legacy systems through our orchestration layer to feed in how to help these operators, whether they're like operating 5 trucks or 50 trucks or 1,000 trucks, to figure out how to do better service optimization, fuel optimization, routing and all of that using the analytics dashboard that the fleet service company was trying to put out for all these independent operators. On the other side, we are now expanded into the distribution of it because all these operators also consume it in different formats, APIs or web services or SOAP services or event streams, so we can de-orchestrate the complexity rather than say, here's a new API and then everybody's trying to figure out how do I connect with that and what kind of huge effort that do we need to put in to kind of like transform this economy, right? So we can de-orchestrate as well as orchestrate on both sides, rather than just talk API gateway. So sort of like an API for APIs plus the orchestration layer for specific use cases, and includes a semantic model that allows you to create a digital twin of everything that's being created for regulatory purposes, or even if you throw it on a blockchain, it could be a financial statement of record saying what exactly happened 6 months ago with that vehicle, and what was it doing and what was it. Our approach is basically to land with pilot and expanded commercials. Like I said, mobility is the core around connected vehicles, but we are also looking at adjacencies where we have looked at insuring chemical plants, for example, working with a underwriting insurance company, global one, and so on and so forth. So smart cities, smart grid, smart building. Industry 4.0 is also of interest to us because manufacturing is coming at us and saying how do we solve, for example, an oil and gas company said how do we solve for automated rig maintenance in addition to what we do historically, get the real-time data and merge it with that and even get even more predictive before it fails, because failure means 3 to 6 months of downtime. And there's our contact information to reach out to us.
So my name is Will Tashman. Thank you all for coming today. I'm a co-founder at a company called Uncountable. Uncountable is an AI company based in San Francisco. We help the world's chemistry and material manufacturers develop new products faster. So when you think about the chemical industry today, you may be surprised to learn that R&D operates much like it did 30 years ago. The development of a new display material or a new rubber material still relies heavily on a scientist with deep expertise going through hundreds, if not thousands, of iterations towards an ultimate product. On top of a very difficult chemistry task, they also have a very difficult data management and analysis task. Their formulations are often stored in Excel. Results may be recorded in a different Excel sheet or a lab notebook. Access to internal systems are often difficult to really integrate into their work. And then if they do analysis or statistical analysis, it's often done in an ad hoc manner with rudimentary tools like DOEs. We created Uncountable to help shorten this path to material innovation. So the Uncountable platform serves as a single sort of hub for innovation and efficient development for scientists. Scientists can directly store, sort, and filter through all previous formulations within their own work, or across works from their colleagues across companies, across locations and regions. This helps them to find a much better starting point so they aren't reinventing the wheel within their own company. Once they find that starting point, they can easily create their own formulations, or they can create new ones and then edit the results right back into the system. Now with the structured data in place, they can move seamlessly into analysis and learnings. And on top of this analysis and learnings, we build in a custom machine learning layer that acts as a predictive knowledge, predictive assistant for these scientists. This predictive layer helps them to pull learnings across projects, so not only their work, but what other colleagues working on in Germany or in Korea. That helps to fill in missing or unmeasured outputs, because scientists never measure everything across all their different conditions. It helps to actually allow them to predict how new formulations will going to perform, so they can virtually formulate, change ingredients, change composition loading levels, and see how that affects all the different properties they care about. And then the AI can actually suggest a new optimized set of recipes that help them try and achieve their results faster. Our customers include sort of 20 plus companies across a wide variety of industries, from paints and adhesives to ceramics and coatings to electronic materials and even pharma companies. But they seem to be able to benefit from our technology in a couple of different ways. Whether it's sort of a global operational efficiency of scientists spend less time data managing their own workflows. or it comes from developing new novel formulations like Cooper Standard. We're able to take suggestions from the AI and reach a level of performance they haven't been able to reach before because the suggestions were sort of out of the typical box of experimentation. Or they just take typical material development tasks, those may last 6 months, they may last 2 years, and we try to shrink those down into 2 to 3x type of savings. So we're here today to look for more future-minded and innovative R&D teams. Again, we work across a wide variety of industries here, and so not necessarily specific to formulations, but all sorts of chemistry types. My name, again, is Will Tashman. I'm one of the co-founders here. You can reach out to me at will@encounter.com.